Hopefully this will be the last version of my remote-controlled lead-out guide.
My idea was to install a jack screw with the servo under the leading edge. In order to make room for the servo, the wing cord is extended forward at the wingtip. The solution weighs 1.1 ounces for a weight penalty of about 7 minutes of fuel, but I think I can optimize a bit more on weight. Here are the pieces of my design. Let's see how long it takes to assemble with my magic screwdriver. Wow, that was quick! See how the two airfoils fit together. It was the most aerodynamic design I could think of to fit the servo in where I wanted. It is a simple design and no bell crank is required to drive the lead-out guide. A number 4 threaded rod is coupled to the servo. The rod threads through a blind nut. The blind nut is sandwiched between plywood along with a connecting wire. The connecting wire was cut to length and bent for the control horn of the sliding lead-out guide. This method of attachment makes the design very tolerant to a misalignment between the sliding lead-out guide, jack screw, and servo. I improved the design by supporting the tail of the threaded rod with a washer. This stabilizes the rod's rotation, eliminating most of its wiggle. This is my best overall design so far. It has all the travel I want in fine adjustment, both forward and reverse. There is a small amount of play in the system caused by the thread clearance and connecting wire.
This shouldn't cause a problem because the control lines are always trying to move the guide rearward.
I completed the wing sheeting to give a better idea of how the finished wing will look. As always, I like to keep my servos accessible, so the top sheeting is removable in this area.
This is probably the lead-out guide we'll use in our next endurance attempt. We'll likely increase the wing cord by 1 inch to accommodate bigger fuel tanks, and this will give more room for the lead-out guide servo.